Hey everyone, and welcome back to this class, Advanced Convolutional Neural Networks. In this lecture, I'm going to walk you through the code to output the first few layers of ResNet. Hopefully, this helps to explain any of the nuances you may have come across in your implementation. So the first interesting thing we have here is the ReLU layer and the max pool layer. Again, I don't normally do this in my code, but I did this time to be more consistent with Keras. We just need to make sure that they have the same interface as all the other layers, which means a forward function and a getParams function. Next, we have the partial ResNet class. In the constructor, we define all the layers as expected, the convolution, batch norm, ReLU, max pool, and then convblock. Remember, you can find all of these shapes from the Keras summary function. We also define an input placeholder and get the output so that we can use these in the predict function later. Similar to the other layers, we have the copy from Keras function, which just calls the copy from Keras function on the sublayers. We also have the forward function and the predict function. Notice how the forward function is nice and simple because of the fact that every layer has the same interface, even if it's just applying the ReLU. Next we have setSession and getParams, which just recursively sets the session and gets the params. We'll see why these are useful very shortly. Next we have the main section. The first thing we need to do is get Keras' version of ResNet, since that is our target. To create a partial model, we just create a new Keras model instance and set its output to be the output of the ResNet layer at index 16. Remember that to get this number, you just look at the model summary to find where the convblock ends. Alternatively, you could just print out resnet.layers. Next, we create an instance of our own class, the partial ResNet. Then we create a fake image and get the output from the Keras model, which is what we're going to compare to. Now here is the interesting part. Normally in TensorFlow, you can use tf.globalVariablesInitializer. Here you cannot. The reason is, Keras is also using TensorFlow as a backend, and so the existing Keras ResNet weights are also TensorFlow variables. So you don't want to initialize them. You only want to initialize the parameters of our model. This is why we needed to define the getParams function on each of our layers. Next is another very interesting thing. You do not want to call tf.session to make a new session. This is because in the Keras backend, a session has already been made. So you'll get some pretty strange errors if you try to make your own session. Once we've set the session and initialized the session, we can use the ResNet to get an output. Remember that this is still just with random weights. This is a sanity check to make sure everything goes through without crashing. The next step is to copy the weights from the Keras layers. That part is not trivial, so hopefully you were able to figure it out. Once we've done that, we get the output again, and then check that this output is the same as the Keras output.